All right, let's talk about uniform circular motion. If you have not already, please make sure you subscribe to the channel because I post useful content on science generally, on chemistry, physics, and maths, and they are going to benefit. You're going to benefit from it. So make sure you subscribe to the channel. All right. So uniform circular motion. Now, what is uniform? So taking note of the word uniform because the motion is along a path, a circular path, and the speed is constant. The speed is not changing. So circular because it's moving in the circles. Okay. So and that circle. So since it is moving in the cycle, we're gonna have something like this. We're gonna have our cycle like this. So if a body is moving in this circular path, for example, now it has some peculiarities to it. The first thing is the fact that it has a uniform speed. A uniform speed. And taking note of the fact that I said uniform speed, not uniform velocity. The velocity is constant in magnitude. So magnitude of velocity is constant, but the direction of velocity is changing constantly. So, and that is why the velocity is always acting tangentially to its path of motion. So its path is always acting tangentially. So this is provided that this body is moving in the anti-clockwise direction. Are you getting it? So we said that there's a uniform speed, but there is what? A changing what? A changing direction of speed, right? Of velocity. So since if velocity is changing, what quantity do we talk about when velocity is changing? Acceleration. So it means that acceleration is what? Acceleration is what? Involved. And acceleration is body. So it means that the body is constantly what? Accelerating. So and what produces acceleration? Force. God bless you. So according to Newton's first law of motion, we have that what? That a body inertia, the body will remain in a state of inertia unless acted upon by what? By an external force. By an external force. So if an external force does not act upon, what it's saying is just that the body will not change its speed. Is that okay? So for the body to be changing direction of its velocity per time, then definitely there is a force that is acting upon it. But you see, the force that is acting upon it is always acting. So if, for example, this body was held onto a rope, for example, it was held onto a rope, and it was swelled round and round and round as it goes here, for example. So it was being whirled round. This body is going to experience, there are two frames of reference, and that is actually very important. Frame of reference. So according to physicists, it depends, this frame of reference it's just another way, a scientific way of talking about your point of view. Is that okay? So my point of view here is going to differ. So for the body is going to feel as though it will be strung away from that path of motion, as if the body were to be was being flung away. Do you understand? So that is what the body is going to experience. But in actual fact, what is going to happen to the body is that it is going to there is going to be a force that is directed towards the center, which is the tension on the string. Do you understand? So the tension of the string. Now, there's another two frame of reference. The tension of the string, as felt by, for example, if it was my hand, as felt as my hand, the tension of the string is going to be along this path, for example, along any particular instance here, is going to be as if what? It is flying out, as if it's going to go out, isn't it? The string, when you are swirling that in, the rope would look as though it's going to cut away in a straight line. But actually the force, so that is from our own frame of reference, but actually the force is acting in this direction. And that force we said is what? It's what's called centripetal force. Centripetal means directed towards the center. So centripetal force. Is that okay? We're going to get into the maths, the entire maths later. But I just want us to understand what those forces are. So I said there are two frames of reference. I will feel as though there is a tension acting in that part, and then this force actually acting in this direction. But either way, you will notice that the force is always what? Perpendicular. There is perpendicularity between what? The velocity, because we said the velocity is always moving what? the direction that is tangential. Tangential. So you see there is a 90 degrees. There are 90 degrees between velocity vector, let's say vector v and vector f. So there's a perpendicularity between them. All right. So and another thing you should also notice is that by the change in direction of velocity, we mean that we have an instantaneous velocity. We have instantaneous velocity at each point. All right. Another thing to talk about, to see here, is the fact that okay, that's basically all we have to see. So let's talk about these 2 points listed here. I said angular displacement. These are some properties that body that is moving in a circular path is going to possess. So since this body, let's still use this diagram. Are you getting what I'm saying? So we have angular displacement and velocity. So let's talk about the angular displacement. The angular displacement is denoted by theta. Why? Because it is displacement of an angle. So for example, if this body starts from here, once it begins to move like this, it's going to be opening an angle, isn't it? It's going to open a particular theta. Do you understand? So that's why it's called what? Theta. So since the theta will be changing as the guy is moving, we have a change in what? In theta, and that's what angular displacement is. Now, what is now angular velocity? Angular velocity is denoted by omega. Now, omega is basically the angular velocity. And what is angular? What is the formula for velocity? The change in displacement per what? Per time. So it is. So this is going to what? Yes, the change in speed, change in distance per time, change in displacement. In this case, we are talking about a vector quantity. Is that okay? So that is a vector quantity. So that's why it's a change in displacement. So that is change in angular displacement per what? Per unit of time. Do you understand? So there is a change in angular velocity per time. So that's what angular velocity is. So this is going to be our first formula. Now there's something also called the tangential velocity of the body. Now the tangential velocity of the body is essentially different from the angular velocity of that body. The angular velocity of the body is the amount of angles that it is covering per time, while the tangential velocity is the velocity that this body is experiencing along its path. Do you understand? So that as it is moving round the circle, if it moves round the circle, it means that the angular velocity, the tangential velocity, is going to be the v, which is going to be since it's moving the entire circle, so it has moved the circumference of the circle over the time taken to move in that circle, in that circumference. So that the v is going to be, what's formula for circumference? 2 pi r. Is that okay? So it's going to be 2 pi of r over t, since it's moving in that. Now, it is not always going to be r, because, for example, the distance moved could be just, it might not be the entire circle. So, but no, it's always going to be r, because this is it's just about the hand, and that brings us to this. That brings us to something, which is the fact that there is a difference between tangential velocity and angular velocity, and this is the difference. Look at this wide circle and look at this smaller circle. Now, the angular velocity, provided that it is the magnitude of the forces that are producing their acceleration, their centripetal acceleration, is the same for this body and this body in this smaller circular path. Provided that the force that is producing those forces are going to be the same, what you are going to notice is that the angular velocity is going to be the same, but the tangential velocity is going to be different. So you will notice this body move a little faster from your frame of reference. This body is going to move a little faster than this body, than the body in this wider path. So because it's moving faster, they have different tangential velocity, but the same angular velocity. Why? The tangential velocity will be relative to what? To the radius. So see, the radius of this is smaller, while the radius of this is bigger. Do you understand? So that's why the tangential velocity is 2 pi r over t. Now, what if the body did not move the entire circle? If the body only moved this distance, how do we calculate that? So let's call that distance s. So what is the distance moved? The distance moved is going to be just Do you remember, if you remember in mathematics where we did length of arc, because this angle is just an arc of the circle. It's just an arc. So what did we say formula for length of an arc was? It's just the amount of angle moved out of the total 360 degrees, the amount of angle moved, isn't it? It has covered an angle, isn't it? Times the entire length, which is the 2 pi r, the entire circumference of the circle, right? Which is what? Theta over 360, therefore, times 2 pi r. But since in physics we might not be given, in mathematics we'll be given the angle, say 80 degrees, 120 degrees. But in this case, we've provided our answer an angle in radians. So if our angle was to provide in radians, then S would be theta over 360 in radians. Then what? It's going to be 2 pi, isn't it? So times 2 pi r also. So what do we have? 2 pi takes care of 2 pi. And then S, therefore, S will be equal to what? Theta r. And that is our equation. So this will be equation 3, equation 2. And this will be equation 3. So let's begin to work around some things. Let's just work some maths around all these equations. We are going to still talk about some terms, and that's where we're going to end it. So how about we talk about so since we already know that from 1, that is that. So from 1, we know that this guy, theta, is going to be what? Omega t. Okay? So we can sub that into this equation so that our S can become what? Our S can become what? Since S is theta r, S can therefore become what? Omega t times r. Isn't it? Okay? Another thing we can do is that we can find the time to what? S over what? Omega r. You see, you can just begin to work your maths around all of this. You can begin to work your maths around all of this. So that that's basically it. So then there's something about this, which is the fact that, okay, let's go on to talking about some other properties that this guy is going to have. Since it's going to be a circular motion, it means that it is covering the same distance pattern. What is that distance? It's going to be the circumference of that circle. So since it's covering the circumference of that circle pattern, then the motion is said to be periodic. So it's going to have a property known as period. So the period is the time taken for that body to cover a circle, to move in one complete circle. So it's what? The time taken per what? Revolution. Do you understand? So time per revs. So time taken to complete a revolution is going to be the period. All right? So then it's going to have one other property that is known as the frequency. Now, frequency is related to speed in a way. Because the body, when we do these two, we said one will be moving faster, the other will be moving faster, the other will be moving slower. So what does that mean? It means that one will be covering this distance faster than the second one, isn't it? So, and the amount of revolution per time is going to be the what? The frequency. It means the frequency is the rate at which revolution is covered. How that is clear? So it's going to be what? The number of revolutions that it can cover per time. Time taken to cover the amount of revolutions it can cover per time. Do you understand? So that's revolution per time. And what did you see? That F, so this period is given by, depending on the convention used in your textbook, you can have P or T. So T is equal to time over revolution. And frequency, small f, usually that's what it's denoted by, is what? It's going to be the inverse of period. Why? Because you see that this period is time per revolution, so this guy is what? Revolutions per time. So that is frequency. So we can also work some math in here. So from what we see here, if our angular speed were to be talking about the entire circle being moved, so if we are moving around the entire circle, so which will be our new theta now, then the entire circle omega will now be, the theta will now be what? 2 pi, because we have moved around the entire circle, right? 2 pi radians over t. So since t is going to be period, the time taken to move around that entire circle, so this equation, let's just call it 4. We're just working around math here. So let's call this equation 4. So from here, we can come back to saying that, let's bring this up here, that omega is also going to be equal to, you know that t is inverse, f is inverse of time. Therefore, t can also be what? The inverse of frequency. Just work the mass, cross multiply, and you have your stuff. So, since it's the inverse of that, omega is therefore equal to what? 2 pi times 1 over t, isn't it? 2 pi times 1 over t. And 1 over t is f. 1 over t is f. So omega can therefore be what? 2 pi f. So that's where that formula comes from. In case, because in the next video, we're going to be talking about simple harmonic motion, where we need to understand where all of this is coming from. All right. So, what else have we not talked about? We have talked about the frequency, the period, and that is that. So that will be it for this video. In the next video, now you can work your math around all of this equation, plugging in values, removing them, and just playing with it, playing around with it. In the next video, I'm going to be talking about simple harmonic motion, and thereon we'll talk about waves, and that is our goal for this series, to go over those motions that are alike. So do well to subscribe to the channel so that you don't miss out whenever I release all those videos. God bless you as you hear this content and like it. God bless you.